Good morning. This is Dr. Sharna Mounty, Assistant Professor in Mathematics, Government First Grade College, Jevargi, Gulbarga University, Gulbarga. In this video, we will go for the Fourier series and their examples. Before going to the example, first you should know about the Fourier series. In the various engineering problems, it will be necessary to express a function in a series of sines and cosines, which are periodic function. Most of the single valued functions which are used in applied mathematics and which can be expressed in the form of the series, and that series is what we can say that it is a Fourier series. And this Fourier series is a function of f of x to be defined in the periodic function if there exists a real number t such that f of x plus t is equal to f of x for all values of x. The number t is a periodic of the function f of x. For this period, the series we can express it as f of x is equal to a naught divided by 2 plus summation n is equal to 1 to infinity a n cos n pi x divided by l plus summation n is equal to 1 to infinity b n sin n pi x divided by l. So that means the function is defined on the interval of the length other than 2 pi or 2l. The arbitrary interval of the length 2 pi or 2l may be taken as c, c plus 2l interval, and it may be denoted that sine of pi x divided by l and cos of pi x divided by l are periodic of the period 2l. Thus, the trigonometric series, we can say that the function f of x, which is the Fourier series of the period 2l or 2 pi. In this series, the function f of x, a naught, an and bn are the Fourier coefficient according to the Euler's formula. And this formula we can define as a naught is equal to 1 divided by L integral c to c plus 2L f of x dx. An is equal to 1 divided by L integral c to c plus 2L f of x cos n pi x divided by L into dx, and Bn is equal to 1 divided by L integral c to c plus 2L f of x sin n pi x divided by L into dx. And this particular of if L is equal to P, the Fourier series f of x is the period 2 pi in the interval c, c plus 2 pi or 2l. After knowing these things, we will go for one example, which is expand the function f of x is equal to x square as the Fourier series in the interval minus pi, pi, and hence deduce that pi square divided by 6 is equal to 1 divided by 1 square plus 1 divided by 2 square plus 1 divided by 3 square plus 1 divided by 4 square plus dash dash is equal to pi square divided by 6. Before going to the solving the example, already we know the Fourier series formula and the Fourier coefficient of a naught, an and bn formulas according to the Euler's. That is the solution. Given that the function is f of x is equal to x square, which is expressed in the interval minus pi, pi. We know the Fourier series as f of x is equal to a naught divided by 2 plus summation n is equal to an cos nx plus summation bn sin nx, where a naught is equal to 1 divided by pi, because the interval is in terms of minus pi comma pi. Instead of L, we have to take it as a pi. So that is a naught is equal to 1 divided by pi integral minus pi to pi f of x dx. An is equal to 1 divided by pi integral minus pi to pi f of x cos nx. Pn is equal to 1 divided by pi integral minus pi to pi f of x sin nx into dx. Here f of x is equal to x square is there. So the first Fourier coefficient is a naught, that is 1 divided by pi integral minus pi to pi f of x dx, and that is equal to 1 divided by pi integral minus pi to pi f of x means x square into dx. Integrating of the x square, it is x cube divided by 3 in the interval minus pi to pi. So applying the upper limit and the lower limit, we will get it is 1 divided by pi integral that is a pi cube divided by 3 minus of minus pi cube divided by 3, and that is equal to 1 divided by 3 pi. Pi cube plus pi cube is 2 pi cube. So it is a naught is equal to 2 pi square divided by 3, because the denominator pi and the numerator 1 pi, it will be cancelled, and a naught is equal to 2 pi square divided by 3. And the an value, which is 1 divided by pi integral minus pi to pi f of x cos nx into dx. See here, f of x is x square, and we know that the function is even because x square is there, and also we know that the function cos nx is also even function. According to the odd and even function of the Fourier series, both the terms of the an Fourier coefficient is even. So that is we can rewrite the formula as 2 times of the integral 0 to pi f of x dx. So that is the above an values we can rewrite as 2 divided by pi integral 0 to pi x square cos nx into dx. Using the formula for the by parts rule, that is the integration by parts rules, that is integral of u into v dx is equal to u v1 plus u dash v2 plus u double dash of v3 minus u triple dash of v4 plus dash dash. That is u dash, u double dash, u triple dash are the derivatives of the function, and u1, u2, u3, u4 are the integral terms of the second term of the integral. That is first term is x square and the second term is cos. Using this by parts rule, we can solve the integral 0 to pi x square cos nx dx as 2 divided by pi the bracket x square sin nx divided by n plus 2x, that is a differentiation of x square is 2x, and integration of cos nx is sin nx is cos nx divided by n, and multiply by n is n square, minus of the differentiation of the first term, it is 2x, and integration of cos nx is minus of sin nx divided by n cube. Applying the upper limit and lower limit, we will get it as 4 divided by n square into minus 1 to the power of n. So an is equal to 4 divided by n square minus 1 to the power of n whole to the power of n. And in the same manner, we can define the bn value, that is 1 divided by pi minus integral of minus pi to pi f of x sin nx into dx. Here one function is even and another function is odd. So that means the integral 1 divided by pi integral of minus pi to pi x square sin nx into dx. Using the same by parts rules, we can write it as 1 divided by pi minus 1 by n square cos n pi minus n square cos n pi plus 2 divided by n cube cos n pi minus of cos minus n pi. and using that way all the cancel terms we will get it is bn is equal to 0. If before solving by you are using the by parts rules in the Fourier coefficient bn, first see that the function f of x is even and sin nx is odd term. So multiple of even and odd term, the bn value is 0. Directly we can write it if we know what it is the property of the odd and even function. So that means the values of an, a naught and an, we can say that it is a naught is equal to 2 pi square divided by 3, an is equal to 4 divided by n square of minus 1 to the power of n, and bn value is 0. Using these three values, substitute in the Fourier series equation. By that we will get f of x is equal to x square is equal to 1 divided by 2 into 2 pi square divided by 3 plus summation n is equal to 1 to infinity 4 minus 1 to the power of n divided by n square cos nx plus 0. So that is x square is equal to pi square divided by 3 plus summation 4 times of minus 1 to the power of n divided by n square cos nx. Substitute because we need the deducing of the pi square divided by 6 is equal to 1 divided by 1 square plus 1 divided by 2 square plus 1 divided by 3 square plus 1 divided by 5 square we need. So that is we have to put x is equal to pi in the above series. By that we will get it is a pi squared is equal to pi cube divided by 4. Pi square is equal to pi square divided by 3 plus summation 4 times of minus 1 to the power of n divided by n square cos n pi. That is first term pi square divided by 3, take it left side, it will be pi square minus pi square divided by 3 plus 4 times of summation n is equal to 1 to infinity minus 1 to the power of n into minus 1 to the power of n, because cos pi value is minus 1 and the cos n pi means a power of n. So that is pi square divided by 2 pi square divided by 3 is equal to 4 times of 1 to infinity minus 1 to the power of 2n divided by n square. Pi square divided by 3 is equal to 2 because 2 is a 4, it will cancel, and take the expansion of the summation, we will get it is a 1 divided by 1 square plus 1 divided by 2 square plus 1 divided by 3 square plus 1 divided by 4 square plus dash dash. Taking the multiple of 2 to left side cross, that is pi square divided by 6 is equal to 1 divided by 1 square plus 1 divided by 3 square plus 1 divided by 4 square plus dash dash, and this is the deduction part of the example and some references that I have taken for making this video. Thank you.